and welcome to another ASMR coding video. Today, after a bit of a break because I had to finish my thesis, we are back with a request of some of you guys, and someone wanted me to do some data structures. So today we're doing a linked list in Python, and I'm back here in Google Colab as my development environment, and I would say we just jump in. So a linked list is a list, as the name says, but it consists of nodes, so individual save points for your data. For every item you want to save, you have a node, and each node has a pointer to the next node. So each node knows who the next in line is, and the list itself has a pointer to the first node. So everything is just connected by this reference to the next point. So the first thing we'll need is a node. So we'll create a class and we'll call it node, and the class needs an initializer, and the node will also have a value, and we'll just save integers, for example, in it, or maybe we'll have string value, and this value will be saved in the node. And like I said, it will also have, I can also write this below, a pointer to the next node. And at first, of course, there is no next node, so we'll save none there. And that should be all for the class. And now we need an empty list, or we need to create a structure for a list. So we'll say class linked list, and it also needs an init method, of course. So it needs to take self and maybe no node at first. We can create an empty list, and then this needs to keep in mind what the first one is, and that's called the root of the list. Root is also the origin point of a tree data structure, for example. Oh, maybe it's called head. Let's call it head. But in a tree, it's called a root. Okay. And of course, at first, that's also none. And none, because it's quite useless like this, we will also do an insert method. Insert at head, or maybe at first let's always insert at the back of the list. So insert last, let's call it that. That also needs to take self, and then the new node that we want to insert into the list. And now I think we need an if here, so if self head is none, then we just want the head to be the new node, so if the list is empty. And otherwise, we go through the whole list and we'll take a current node and set that to head. And now while current node next is not none, so that means there's still items in the linked list, we want to go one further in the list. So we'll update our current node with which we started at the head, and we say current node is current node next, which we have just checked in the line before that it is not none. And then if current node next is none, then we say current node next equal to the new node, because then after this while loop is finished, we're at the end of the list. Alright, and now, so that we can see if the linked list is working, we also do a print method. So just call it print, also path self. And now let's do current node is self head at the start, and then we go, we print while current node is not none again. We print, let's also keep an index. Then we print index, index, and then the value. So current node dot value. And then we'll go one further in the list. So current node equals current node next. And we'll also have to increase our index by 1. That should be good. Let's run this. And now let's create a list, an empty one. So just call linked list, parentheses open and close, and then also load A with node, and then the value will just be first. Let's run this. It also seems to work. And now we will insert last node A. And now we can print our list, and it should output that there is this node in there. My list print. See, at index 0 there's this first. Oh, I mean, we could also call it tomato. Rerun this. And then we see that at index 0 we saved the word tomato. Now let's add another one. Insert last, and then we just create it in here, and we'll just save salad. And then we will print the list again. Run this. And now we see we have tomato and salad. Alright, now let's do something a bit more tricky and delete things out of the list. Or I guess for that one we should also add, let's say, cucumber. So we have at least 3, then we can delete something from the middle and stuff. Alright, let's go back up and write a delete method. So def delete, and that will take an index where we want to delete it. So now we will also count, let's call that one the delete index. And now we have our own current index, start at 0, and the current node will be self head. Now let's assume that the delete index is valid and the list is long enough. So now we need to check while the current index is smaller than the index where we want to delete, we advance we're saying current node is equal to current node next. That's a common theme, as you might see. And the index will be one bigger. And then if we are at the point where the index is equal to the delete index, then we will, oh right, I remember. We also need to keep in mind the previous node, because we skip one of the links, so we need to take one out in the middle. So let's go back down. We need to take out the salad, but the salad points to the cucumber, and if we just delete the salad, then like there's no connection between tomato and cucumber. So we need to remember a pointer to the tomato, and then we can say, if we want to delete salad, we see, oh, salad points to cucumber, and then we say, oh, tomato, you now need to point to the cucumber. So we need access to the next and the previous node. So the way we do that is by always keeping the previous node in here, and we can make it here, previous node is current node. Is that how we do it? Maybe. We'll see if it doesn't work. Okay, and then if we are at the index where they are both the same, so we are at the one that we want to delete, then our current node is the one that we want to delete. And then we will simply do previous node next is equal to current node next. And I don't know, that should work, maybe? I mean, okay, it doesn't work if, let's also write that. There might be a smarter way to do that, but I'm just winging it right now. So if the delete index is 0, this doesn't work, of course, because this assumes that we delete something in the middle. The way we wrote this, it also works for deleting at the end, because then this will simply be none, and then the previous node will point to none, and that's fine. Then that will be the end. If the delete index is 0, we don't need to do anything with previous node. So if, okay, let's just do this at the very start. So if the delete index is 0, then we just do self head is equal to self head next, maybe, hopefully, and then we return, then we're done. Okay, let's see if this works. Can we, let's print again. Okay, I don't know if we need to recreate the list now, but we'll see. So delete, add index 1. Let's delete the salad. No. Yeah. We need to recreate it, so let's write this again up here. So let's just do linked list and then insert all of these again. So we had tomato, salad, and then cucumber. Then get rid of this cell and this cell. Let's recreate this, print this, and now delete it, and then print it again. And now we see that salad is gone and we have tomato and cucumber. Let's just put this behind this. Let's now delete the head, so then we assume that we only have cucumber left. And that also worked. Nice. I guess now we can delete that one. I mean, that's now at the start and the end. I wonder what happens then. Yeah, it's empty. Okay, so that seemed to work alright. Okay, so deleting works. I guess we can also do a bit of a more tricky insert. Instead of just inserting at the end, we could also insert after a given index. And we'll just do this for practice as well. So def insert after, and then we'll get an insert index and a new node, and I think we'll also differentiate if the index is 0 or not. So if the insert index is 0, then self then new node next needs to be the current head, and then we can override the head. It's important in which order you do things because you don't want to lose any of the pointers. So new node next will be the head, and then the head can be the new node, and then we're done. But if the insert index is bigger, we again start with index equals 0, and the current node will be the head, and while current node next, while the index is smaller than the insert index, we will do we advance one node by saying current node is current node next, and we advance the index by increasing it by 1. And then when we're done, we do current. I don't think we actually need the separate if statement if I'm correct, but let's just finish this part. So we first need to we set the next index of the new node by setting it to the current node next. Oh yeah, so it's still a bit different than above. Okay, so current node next, and then the current node next will be the new node. So it's still a bit different than up here, because even if current node was head, then here we need to access next in the below part, and up here we just wrote head. So I think it's still a bit different, if I did it correctly. Okay, that seems alright. Let's run this. Now let's see if we create a list again. And now let's insert after index 1, so after the salad, we will insert a node with, let's just go with another sandwich food, and let's put cheese on it. We'll just imagine it's a sandwich. I mean, there's no bread at it, but we can fix this. Okay, let's insert after the salad the cheese, and then we will also print it. See, that worked. Tomato, salad, cheese, and cucumber. And to make it a sandwich, we need to insert at index 1 bread, the end we also need to. So after, oh, I noticed something, but okay, after index 4, insert bread. So after index 0 doesn't do it correctly. Currently, if we enter 0, we enter it at the head, which is not what we wanted. I mean, it's not what the method name says, so that's not quite correct, but look, our sandwich is finished, so that's like the main part. Okay, so this here just inserts it at the head, and let's make a separate insert first. So let's do this here, because it's not really correct the way we have it here, and then I think it should work without the if statement. If we want to insert it after index 0, it should work like this. Let's run this again. So if we want to, now we can try insert first with the bread. Yep, that works. And now insert last, also bread. Yep. And now if you want to insert something after index 0, that would be my list insert after, and then 0, and then node chicken strips. Do you call them that? I don't know. And then print, and then that should be between the bread and the tomatoes. Yeah, now it's the expected performance instead, the way that I did it there. So I think that's all of the things that we do with a linked list. And so I'll wrap up the video here, but I promise there'll be more videos soon. And I hope you learned something, but also relaxed a bit while watching me code a linked list. Thank you for watching, and I'll see you in the next one. Bye!